This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 101, a review of what is new in Ansys Additive 2021 R2, and an update on news and events. Hi there from southwestern Colorado, and to be specific, from our car in the parking lot outside where we're staying in southwestern Colorado. It's 32 degrees outside, so I can't record this outside and I don't want to wake anybody up inside, so I decided to come out in the parking lot. So I apologize for the heater noise in the background, but I don't want to die, so I'll have to put up with that. But yeah, it's the 15th of November in the morning here in beautiful southwestern Colorado, and the sun is rising behind me. It's kind of an orange and purpley thing going on, and I hope everybody has a fantastic week. I'll be driving back to Arizona today after we pack up. But I just wanted to thank everybody for joining us for the 100th episode, and here we are at episode 101, and let's keep going and keep hopefully adding value to your Ansys experience through this podcast. The interview today that we're going to talk about, or actually listen to, is with Doug Oatis. I sat down with him when it was warmer outside on my back balcony on Microsoft Teams, and we talked about Ansys Additive 2021 R2. So let's listen into what Doug found interesting in that new release. In the same state, I'm down in Pagosa Springs on a little mini vacation. Doug, how's it going?
Good. You're only, 6 hours away instead of 14?
Yeah, one would argue the other side of the Rockies and the other corner of the state,
right.
But it is the same state.
Right.
I still can't buy beer in the grocery store, so I must be in Colorado.
No, you're going to the wrong grocery store. We got rid of that law a while ago.
Well, yeah, the store here by the continent doesn't
simpler
have it.
Times.
Yes, back in the old days. Maybe this county is a dry county and they just
right.
Well, we're not here to talk about liquor laws in the state of Colorado. We're here to talk about Ansys Additive and other stuff. So
I came prepared with liquor laws. The content. This is a mistake on my part.
Yeah, going across the line to New Mexico, I might have to go.
Bootlegger.
Anyway, bootlegger. So, yeah, so it's been 6 months or so since we looked at what's new in Additive, and this release seems to be a lot of fixes, a lot of beta features, and things like that. So, what's your most favoritist thing that they put out? Got you most excited?
I mean, the big one that you'll see is like the variable layer height. So, and I mean, you kind of have to. I tried to explain this during the webinar, and I probably just completely butchered it. But when you're solving the model, depending on how you mesh it, you're essentially, the mesh is aligned in the print direction so that each kind of layer height of elements represents a certain amount of powder, deposition layers and stuff like that. And so, if you want to use like old school FEA terminology, it's almost like a super element. Each one of these is a super, each finite element represents a super layer of actual printed powder. And so based off of the machine parameters, we come up with, different thermal boundary conditions for that.
Okay.
So there's really no reason that you can't group super layers into super duper layers kind of thing. And so build, so rather than the thermal solver, turning on a layer, applying thermal loads, and then lather, rinse, repeat your entire way up the build process, you just print or turn on 4 layers at a time, or however many layers you want. So there's awesome way to speed up a simulation, but it's one of those it's a Spider-Man situation where great power comes great responsibility. So the gross behavior shouldn't change that much, but you kind of have to use it intelligently. By that I mean, if you have a lot of support structure, a lot of kind of thin parts that you're printing, and then you come across and you kind of cap off, depending on whatever you're printing, whatever the shape is, as soon as you start changing that cross section in the print direction, now you're going to start introducing all these kind of weird strains that develop as the part starts fighting itself. And so, it's one of these, like, I think it's great. I think it's a great way if you have a large amount of support structure that you're using in order to print, you can race through that. And now you can actually get to the meat of it. So one, you have to use it smart. Two, you have to use a command snippet. And to make it a little more, hand wavy, in the command, you don't say print one layer at a time. You actually specify print a dimensional height.
Oh, okay.
And so if you look at the command, it's using that AM build, and there's like 2 or 3 commands in there that I always get lost in. And so you kind of have to be careful. One, it's a command snippet and it's units. So make sure that you're consistent when you hit solve.
Right.
That's right. So that's the big one. That's been one that they've been, we've been talking about it for a bit. And so this is the first time where I've seen it, use this kind of thing. And so the nice thing is, all of the documentation, and we got an email from the webinar. Someone was asking for information on all the additive stuff, and a lot of the additive documentation is actually really good. Comes with links to like download things and all sorts of stuff. So I mean, there's a full example on how to use this in the release notes. So
definitely want to use that example then, because if it's something you got to play with, definitely.
Yeah.
Good.
And then I'm just trying to think of the other ones. The AM bond macro, that is the way that you connect a voxelized STL support structure, which just sounds like I'm making up words off of the number of adverbs in that statement. But it's a way, it's like the old school CEINTF, or kind of tying together dissimilar meshes. And what happens is, if there's any kind of penetration or significant penetration between these two node patterns, you wind up with all these weird spikes as you start. As you're running your simulation, all of a sudden you get these weird spikes that don't make any sense. The fix is you just go back, blow that away, or remove that from the AM connect, and then put bonded contact. But each rev, this gets a bit better at dealing with those kind of things. So that's the good thing. And
good.
One thing we didn't talk about was, so I was talking about Workbench Additive.
Yes.
So there's multiple products here.
Right.
So Workbench Additive has that. There's also kind of not cleaning house is completely the wrong word, but combining methodologies that are available in additive print versus Workbench Additive. So, both of these tools, you really want to go through and like calibrate it against your machine. And so the way that you do that is, you have, I forget whatever, there's certain standardized parts that you can print. You measure the distortion, you plug that in, you see if you can match it. And basically it's kind of a direct optimization technique. So additive print I actually really like it just from the simplicity standpoint. Like, you go to the additive print, this is outside of Workbench. If you're calibrating that software, you download this package, it comes with an Excel file, you punch in your numbers, it says, hey, maybe try this number. Nice. So it's equation driven. So what's happened on the calibration side of Workbench Additive is that there's an equation driven optimizer. So should just basically converge a lot faster than the whatever space filling algorithm. It's like an LP. It's like 6 letters long. I'm not going to pretend to be an
lots of abbreviations.
Yeah. Pour out a can of alphabet soup, and you'll get the name of an optimizer space filler technique.
Apologies to the people who did.
I only say that because I'm not smart enough to remember what it all stands for. So it's purely an insult to me. So then, after that, this is the first release where I've seen, advertised improvements to the additive science suite. And so additive science, that is the toolkit or the tool set that you play with machine parameters. You can link a porosity to look at fusion performance, so to make sure, you're not running your machine too fast or too much power. And so that solver's been on the porosity side. It's been optimized, and then on the microstructure, so predicting the grain structure, that's a two-stage solve. So you solve for the thermal performance, what happens thermally, then you solve what happens mechanically. And older revs, only one of those solves was parallelized. So now they're both, or the majority, 90% of it's been parallelized. Good. So should be able to get significantly better scaling on more cores. So those are the two big ones. And just to make it even more confusing, I'll talk about beta at the very end.
Okay, we'll talk about beta at the end, yeah.
And so, then the other thing on, shape or any optimization. So on the Workbench project page, it's not topology optimization anymore. Because that was a lie anyways, right? It did more than topology optimization. Yeah, it was a lot more, yeah. It is structural optimization. So that's where you'll find topology optimization, shape optimization, lattice optimization. So if you're playing around with infills, you're playing around with, distorting the mesh or a standard topology optimization. And even that has two different methodologies to it.
Right.
So, the nice thing is a lot of the updates or the highlights are on the shape optimization and having it work off of stress. And so what you can do is you can feed it, kind of a standard fillet or chamfer, however you want to connect two different parts, and then it'll kick the nodes around and reduce the stress. And not only reduce the stress, and you'll see, big savings there, but you can also work on accumulated plastic strain. And so that way you can run a simulation and capture if there's yielding, or you can run it and have it basically morph the mesh so that you're no longer getting yielding. Nice. So, this is great from, this isn't additive specific. So it's obviously going to depend on what your manufacturing capabilities are. But if you're just trying to do a real quick pass and come up with an optimized simulation and just make sure that, you have some hope of surviving a fatigue environment. The very worst thing that you can do in a fatigue environment is yield it, right? Exactly. And so you can try to knock down that stress as much as you can before you ever go into, your validation simulations to look at your fatigue performance. And so, those are the big ones. I think there were like 4 or 5 slides just going over the stress and plastic strain optimization.
That's handy. I think that's one of those things that people had to kind of do by hand in the past. So good.
Yeah. Any type of nonlinear behavior is tricky in, a gradient solver, right?
Right. It's just, exactly.
And
it's no longer linear.
Right. So, that's the big one. And then, so last rev, we introduced the concept of, you can use, when you set up your simulation, the objective is, I want to minimize or I want to maximize my compliance. And so basically make it super stiff or super soft. Right. On the structural side, last rev, you had the ability to actually specify like what should that essentially strain energy be. So if I want to make sure that I'm whittling away material, but I don't drop below a certain load carrying capacity, obviously a little bit kind of a power user, you have to, power user in the sense that, you kind of have to know how stiff your part should be, how much load it needs to, and obviously all this is going to depend on like, the deflection and the load and all this other stuff. So that was last rev on the structural side. Same thing now appears on the thermal side. Okay. So, and I keep on trying to wrap my head around, because I think you enter it in terms of watts per, I can never remember if this is bad, like is watt power or energy. It's something like it's watts per C, not per C. It's a watt Celsius kind of. It says the units are a little odd to me. I need to.
That is a little odd. Yeah.
I need to sit down and wrap my head around that. But it's really, it's the same thing.
Thermal stiffness of the part.
Yeah. The thermal compliance, making sure that, regardless of whatever constraints I have, I still have the same ability to transmit heat through my part. So again, that's kind of a power user, but it's a any type of power user tool is a feature is a good thing.
Yeah.
And so and then I think there's some cool beta stuff. And I feel bad because I'm like I feel like I'm like it's that meme of like the guy walking with his girlfriend and another girl walking behind him, and it's like
all that is really cool.
I'm like I'm walking with these release features. I'm like, ooh, what are these beta features? And it's because the big one to me is the directed energy deposition.
Yeah,
why doesn't that
that's
right
exciting. Yeah.
So it's exciting for a couple reasons. One, that's technically been there. You just had to know your way around APDL and how mechanical structured everything. So it was there for like 2% of the population maybe. And now there's a wizard that walks you through it. So you have to download it, install it, that kind of stuff. But it's also the first time that G code has been, or the ability to read in G code. So if you're not aware, G code is, I actually had to go back and kind of reread it.
Right.
It reminds me of like being in school and like your intro to programming when you would say like to like some turtle or whatever, it's like move forward 10 paces, then turn left 90 degrees. And so it's kind of like those instructions, a bit less verbose, but something like that. And so, you can think of, it has the ability to read G code in order to build groups of elements that are basically, hey, print in this sequence. So from the standpoint of, the ability to do powder bed fusion has always been there.
Right.
But you start looking at other manufacturing methods, and this kind of opens the door to other avenues. And speaking of other manufacturing methods, there's I actually don't remember if this is in the documentation, and I don't want to get in trouble for anything. So
okay,
if you're looking at other methods, there's stuff coming. And if you find it in the documentation in the release notes, then it's
good for you.
I was hiding that secret that everyone knew about. And then the last one, if you turn beta features on and you're running an optimization study, there's an output setting to where you can actually write out. I think it's a VTK output of stresses, displacement, temperature on the actual optimized iteration. So, if you created this optimization simulation, ran it, and asked for a stress below a certain value, in order to actually see the stress that it was being solved for, you'd have to do your entire validation simulation. Now you can specify, write out, all the iterations, the last one, that kind of stuff, and actually view the result on the or basically that whittled down mesh. Because it's a VTK file, you have to have Insight or ParaView in order to view it. But it's the first step to something that is needed.
That's really a powerful thing that we need to have, and well, that's good. I mean, the beta features, they'll be released once they're QA'd, so it's a good thing. And I'm super eventually I'm super stoked about direct energy. That's we've had powder bed, like you said, for a long time, and direct energy is a growing, especially in the rocket business, a growing way to build large structures, and being able to model that's going to be important.
Right. And again, like there's a wizard now that kind of walks you through it. So
good.
it's a there's always that differentiator between, can you solve it and can other people use it? And
right.
So it's like, the math's there. We can definitely solve it. Just making it more accessible is always a good thing.
Well, awesome. That's cool. So the additive suite, like you said, is a big suite. There's a lot of tools in there. There's a lot of little enhancements and bug fixes that we won't need to bother covering. But if you're doing powder bed fusion and now directed energy stuff, you should definitely take a look at what's available now in this new release. And it sounds like fantastic news. The help's really useful. So that's a big help. And the help's useful. Some of the licensing kind of changed, at least from how I remembered. So if this was something that was looked at before, and you only needed one piece rather than all of it, kind of thing. So there's a couple different ways that you can kind of get into the simulation side. Good.
So And I say that now, and I'm blanking on the specifics of it.
Yeah.
I just remember that
it was simplified. I remember.
Well, it's kind of like if you want to do this, you have to have all of this stuff. And now there's a couple other there's basically a different way. Depending on what you're trying to simulate, there's ways to get not to sound like a used car salesman, but we can get you into this baby. Much lower
what do you want your monthly payments to
be? So yeah, depending on what you're doing, there's ways to get into it.
Do you really want your kids to see you drive home from work and that additive tool?
Right.
Awesome. I love it. I love seeing how it's improving over time and beginning to see other technologies in there and getting faster as well. So lots of good enhancements for people doing this. And as always, if you have any questions, definitely reach out. The webinar is in Bright Talk that you gave, I think last week, was it?
Time's meaningless, but that sounds right.
That sounds right. You're right.
October lasted 3 days.
That's right. Exactly
I don't know anymore.
Exactly right. I have no idea literally where I am or what month it is, but I know that it's colder than it was.
Right. You're wearing a jacket, so
I'm wearing a jacket.
Arizona.
Anymore. And there's actually a large body of water in front of me, which is another and snow-capped mountains in the background.
Right,
so I know
it's a large body of water that isn't a flooded Arizona highway.
That's exactly right. Yes. So I always appreciate filling us in on all this stuff, and do check out the webinar if you have any questions. Check out the help if you have any questions, and definitely reach out if you have any questions. And we will talk to you soon. Have a good rest of the week. Enjoy.
Definitely.
Talk to you later. Bye.
Bye.
I always enjoy catching up with Doug, regardless of the topic. The Ansys Additive Suite is a really good one, though, to spend time discussing, and it just keeps getting better and better. If you've not used it before or not used it in a while, and you do metal additive manufacturing, do check it out. Speaking of which, are you looking for 3D printing supplier? Maybe you don't have your own equipment in-house, you have special needs, or your machines are busy all the time. PADT is not only an Ansys Elite channel partner, we are one of the most respected 3D printing service providers in the country. Why, you may ask? For the same reason why we are also so respected in the Ansys community. Our in-depth technical knowledge, ability to explain the technology to others, and how we work side by side with our customers to deliver the solutions they actually need. We have most of the major 3D printing technologies in-house, and you won't really find many places with engineers who know as much as ours do about the topic. So reach out and let us quote your next build, whether it's plastic, metal, color, weird materials, not so weird materials. You need a lot of parts, you need a few parts. Regardless of what it is, if you need somebody you can work with and that is a technical expert, consider PADT for your 3D printing. So let's move on to news. While we were celebrating our 100th episode here on the podcast, Ansys released their Q3 numbers, and the stock market liked what they saw. They made some big gains. They closed on November 4th at 409.97, which is the first time over 400 in quite some time. And they peaked that day at 411, which is just a smidge under their all-time high. So they got really close to hitting that number again. Last Friday, on the 12th of November, they finished at 391.82. So that's where they'll start off this morning in New York on Wall Street. So looking at the data for the year, that's up. Sitting at 391.82 is up 7.7% for the year to date. As comparison, the S&P 500 is up just under 25% for the year so far. Altair is the only stock kind of in the group of simulation tools and CAD kind of related stuff that is up more than Ansys at 35.41%, so they're having a great growth year. Autodesk is below Ansys at 5.9%. Again, Ansys was at 7.7 so far this year. And PTC is up only 1.86% for the year. So not a great year for CAE and CAD stocks, unless you're Altair, but Ansys is definitely doing better. I guess you can't really complain about a 7% gain year over year. But let's move on and look at those numbers that, I never understand how Wall Street works, but I assume they help drive those the stock price up. So they had a couple weeks ago, they announced record Q3 annual account value and cash flow as part of their Q3 financial discussion with investors. So all these numbers are going to be generally accepted accounting numbers, GAAP. And of course, you can do accounting different ways, but this is the way that everybody is using the same measures. So for Q3, Ansys saw $441.2 million in revenue, and that brings the year-to-date revenue to $1.251 billion. And this time last year, at the end of Q3, they were at $1.057 billion. So a nice increase in revenue of a little bit over $200 million through Q3. Profit was $85.3 million for the quarter, and that makes it $251.5 million for the year so far, and that's 15% better than they were at this point last year. Cash is sitting at just over $1 billion, $1.081 billion, and long-term debt is at $753 million. And I usually don't talk about this, but maybe it has to do with the stock price. They are predicting for 2021 that they will end up at 1.86 or $1.9 billion in revenue, with earnings of $4.74 to $5 per share, profit type of a thing. So they're predicting a good end of the year, but not hitting that $2 billion mark. So strong numbers and plenty of cash for what we like, more developers and more acquisition. So we'll continue to see that grow and do better, hopefully. In other Ansys news, there's only one story of note by itself that I'll talk about in a second, but there's a lot of announcements, if you look at the press releases and news stories that Ansys puts out, where they talk about partnerships with large companies or even some small companies. And these are usually where they're kind of work together in a certain area to make the software better and to make the product or the customer better. And since October 27th, there were quite a few. TSMC, the big chip manufacturer, partnered with Ansys for thermal solutions for IC chips. Honeywell partnered with them for safety critical software. Seagate, the disk drive dominant company, is expanding their uses of Ansys. They've been a long-time Ansys user, so they're expanding that even more throughout the company. And then a small company called Oculi is working with Ansys to reimagine how automotive radar systems work. So this is for autonomous cars and using Ansys products to design and play with the radar systems on those. And then the last one during this short period that they announced was Panasonic Automotive is going to streamline their functional safety analysis using the Ansys products. So you can see these are all over the place, from thermal to AI to safety simulation. So some pretty cool stuff going on out there at these large companies, and that usually ends up in better software in the long run. And the last bit of Ansys news was that AGI, a product that Ansys acquired a few years ago, remember that's the mission simulation tool, they won the Presidential Award for Exports. So congratulations to that team. And basically for just selling a lot of software overseas, I think is basically what the award is for. So great job there, and congratulations to that team. In PADT news, we did a press release last week on the fact that PADT engineers were listed in 16 patent awards that were given out in 2020 and 2021. So we were listed, our employees were listed as the co-inventor with our customers or with their previous employer. So pretty cool to see that many different names on patents of 16. And that's the most, actually, that our employees have been listed on for a 2-year period, and really is a testament to the technical expertise and the innovation of our staff. And they were all across the board, everything from 3D printing to golf technology to medical devices. It was some pretty cool stuff to see. And you can check that out. I'll talk about it on a blog post. I also want to point out that PADT continues to grow, and we have a bunch of openings, and many are Ansys related. So if you know someone that is looking for a job, most of these positions are pretty flexible on where they can be. Some are in Arizona, but most of them are pretty much anywhere within our sales territory, or if it's one of the engineering positions, we're being pretty flexible on those. So the first one is a couple openings for account manager, basically helping sell Ansys. We are also looking for an Ansys customization software developer and an application and support engineer that knows mechanical. So the first one would be, using ACT and C# and things like that to write custom software for customers. And the second one is working with our support team, answering support questions and being an application engineer for the mechanical product. We're also looking for a design engineer. embedded software engineer, so somebody that knows how to write embedded code. And then our Ansys sales team, actually our Ansys and Stratasys sales team, is getting so busy that they need to add another administrative assistant to that team to help process orders and help customers out. So that's a great opening, even if you're not an engineer and know somebody that's not an engineer that is looking to work in the world of engineering. It's a great entryway to join our team. And last but certainly not least is with the acquisition of ZMax. Of course, we are looking to add optical engineers to our staff. So if you're an optics person and you're interested in working at PADT or any of these other positions, or you know somebody that is, reach out to us. You can go to padtinc.com and click on the careers tab at the top of the page, and you can learn more about each of these positions and also how to apply. In publications, there's been a lot put out there on the Ansys blog because we skipped a couple weeks of talking about what it was. I picked 3 that I think are worth digging into. The first is a new look and age-old process of mixing simulation. So it's basically how to use Fluent to do, and a cool wizard in Fluent to do mixing in a large tank, which is pretty cool. The second one is reach optimum design and reducing charging time with Ansys wireless charging system analysis. So it's kind of a cool article about how to use HFSS to do this kind of charging simulation, but I really liked it because every time I click my iPhone against that little magnet and it starts to charge, I, of course, think about, well, how does that work and why is it unique and why does the cheap charger that I bought online not work as well as the Apple charger? So some answers to those questions from a simulation standpoint in that article. And the last one that I like is how people are using artificial intelligence and simulation combined together to do better in motorsports. So get around that track faster, basically running lots of different simulations and training your artificial intelligence system using that. So cool use of the technology. I always like auto racing. The only event that I've got on the calendar right now is a webinar on the 17th, so Wednesday, on electronics reliability updates in Ansys 2021 R2. So definitely check that out. Other stuff going on PADT the rest of the year? Well, not much. We're kind of winding down for the year, so we're not going to a lot of events and things like that. And then Ansys-wise, I didn't find anything of significant events there, but I did want to remind folks that if you want to know what webinars Ansys is putting on, what events they're putting on around the world, the best way to get to their event page is just to search on your favorite search engine for Ansys and then events, Ansys events, and it gets to the events page really quickly that way. And they not only have a long list of things going on, but you can filter by region, by product, by interest, so you can really find events that you're interested in that Ansys puts on directly. So that's it from this podcast recording from Southern Colorado in a parking lot. It's a really nice facility. It's not. I think if you want to imagine kind of a cheesy motel along the highway, you can. That's not what it's like. It's actually quite nice, and I'm going to miss it going back to the desert today. So I want to thank everybody. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in and spread the word. Don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 101. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employer. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.